Hey folks, so we are looking at section 11.6. This is the lesson video for 11.6. Make sure if you haven't filled in your notes from the notes video that you go back and rewatch the notes video first before watching this lesson video. So one of the things I asked you in the notes video was other ways that we could write our theta. And I gave you an example here that, all of a sudden we can have a positive radius or we could have a negative radius. All semester long, I have been telling you that you cannot have a negative radius. Today is the day, folks. We have finally arrived at the day where you are allowed to have a negative radius. And I will discuss what that means here in just a few moments. So I could have a positive or negative radius. I could also have a positive or a negative theta. And so, let's see, let's unhide some of these. I could have a positive theta. And if I were to have a positive theta, my radian would look like theta between 0 and 2 pi. If I had a negative theta, then it would be my theta between negative 2 pi and 0. Now, let's first of all look at how to plot polar coordinates. Remember that in the last two sections, anytime that you have the word rectangular, that automatically means that we're dealing with legs. Anytime you see the word polar, it automatically means that you're dealing with r's and thetas. Okay, so rectangular goes with legs, polar goes with r's and thetas. So when we come over here to example number 1, you'll see that I'm supposed to draw the coordinate with a radius of 3 and a theta of 45 degrees. Now, always go get the right angle first. Don't get the radius first, go get your theta first. And so you know that 45 degrees is going to be smack dab in the middle of the quadrant. We know that. So there's the right spoke. And now what I want to do is I want to go out to ring 3 on my spoke. And if I go out to ring 3 on that spoke, you can see that this is where I'm going to stop. So I'm going to place a dot because that's what a coordinate is a dot. One point in space. I'm going to place a coordinate on the 45 spoke at ring 3. All right, well, if we go to the next example, we know what a negative angle is. A negative angle tells us to go the opposite direction. It tells us to go clockwise. And so I'm going to go to negative 45 degrees. Well, we go find our spoke, and we know that this is my right spoke for negative 45 degrees. And once I have my spoke chosen, I'm going to go to ring 3 on that spoke. So ring 3 on that spoke would land me right here. And so I'll put a dot there. Ring 3, negative 45 degrees. All right, let's go do the next one. And all of a sudden, on the next one, we have something totally different. We have a negative radius. So what exactly does a negative radius mean? I like to say that the negative radius tells you to turn around and go out the back door. So let's talk about what I mean by that, first of all. Again, go get the right spoke first. We know that 45 degrees lands me smack dab in the middle of the first quadrant. Okay, if that's the right spoke, which it's almost the right spoke, look at what the radius says. The radius says that we want to turn around and go out the back door. I don't actually want to use my 45 spoke. I want to use the back door spoke, and the back door spoke is the exact opposite direction as the 45. This is what a negative radius tells me to do. It tells me to turn around and go out the back door. All right, so if this is now the right spoke, what I want to do is I want to go find ring 3 on that spoke. So I'm going to go follow ring 3 all the way until I get to that now correct spoke. And I'll put a spot right there, ring 3, at the right spoke, which is the back door spoke of 45 degrees. And again, it's that negative radius that tells me to go out the back door. All right, let's try another one of those. This one tells me to use spoke negative 45. Okay, we know that spoke negative 45 is this guy right here. But because of my negative radius, I can't use that as the right spoke. I need the backdoor spoke. And the backdoor spoke is going to be this guy right here. So there's my backdoor spoke. And I want to use still ring 3. So we're going to follow ring 3 all the way until I get to this spot right here. I'll put a coordinate there. And that's going to be my coordinate on ring 3 at the backdoor spoke of negative 45 degrees. All right, so that gives me a little bit of a practice of how to draw a coordinate. And I'm going to actually do 2 more questions on this, but I'm going to add something to them. So for example number 2, notice that the first thing it says is to plot the point. Okay, no problem. Let's plot the point. We know that we find the spoke first, so the spoke at 120 degrees is going to be this guy. There's my right spoke. And I'm going to stay on that spoke since my radius is positive. Okay, so if I stay on this spoke, I want ring 3 on spoke 120. Okay, so let's follow ring 3. We're going to stop at the spoke of 120. And we're going to draw ourselves a little coordinate there. Okay, so I'm going to change my color here so it's not quite so distracting. I went this direction to get to that coordinate. Okay. Now, I could also go in this direction to get to that same coordinate, and that would be a negative angle. Now, let's look at the directions. Do you see how I was supposed to plot, which I already did, but then I'm also supposed to give 3 more names for the same coordinate? Well, I could, for that coordinate, have the positive version, which I just drew, or I could have the negative angle version. Both of them will land me at the same spot. So if I had the positive angle version, I already know that that was what my given was. The negative angle version, well, what's the negative angle that's coterminal to 120 degrees? And the negative angle is at that spot is going to be negative 240 degrees. Same spoke. I didn't change the spoke. I didn't change the spot. Okay, so that's one way, actually 2 ways to get to the same coordinate. Use a positive radius and either get there with the positive angle or get there with the negative angle. Now, let me erase some of these so it's not quite so distracting. That's all if I'm using the positive radius spoke. But what if I used the backdoor spoke? The backdoor spoke would cause me to use a negative radius. And I can get to the backdoor 2 different ways as well. I can either get there by using a positive angle, or I can get there by using a negative angle. What's the positive angle to get to the backdoor spoke? Well, we know that the positive angle there is going to be 300 degrees. The negative angle, I just erased it, the negative angle is going to be negative 60 degrees. So now I actually have 4 coordinate names that all land at the exact same spot. They all land in this spot right here, all 4 coordinates. Let's try that again. So on this one, notice that my spoke that I'm using is 3 pi over 2. So here's my spoke, and I can get to my spoke 2 ways. Now, the given just tells me to plot the point. So I'm going to follow my ring 4 all the way to 3 pi over 2, and then I will draw a coordinate at the place where those 2 meet each other. So there's my point. I've plotted my point. Okay? Now, we just said that we could get there by using my positive angle. But I can also get there by using the negative angle. Same spoke, so I'm not using the back door spoke. Okay, so if I'm using the front door spoke, that's still a radius of 4, positive 4. But then it's my angle that has changed because now I'm going to the negative angle, negative pi over 2. That's all using the front door spoke. Well, let's go use the back door spoke. The back door spoke is this guy. And if I'm using the back door spoke, I need to be using the negative version of the radius. Well, I can get there by 2 ways. I can either get there by using a positive angle, or I can get there by using a negative angle. My positive angle version is pi over 2. My negative angle version is negative 3 pi over 2. Now, let's take this a little further. I want you to take a look at the directions on this. So this says that we're given a rectangular coordinate and we're supposed to plot. Now remember that rectangular means legs, and folks, this is junior high. I'm just simply plotting the coordinate xy, okay? So you can see here on my picture, I've plotted the coordinate 1, 1, all right? But then the directions tell me that I should give 2 pairs of polar coordinates. Now remember, polar means r's and thetas. And so I'm supposed to give 2 pairs of polar coordinates for that exact same coordinate. Well, this means that I need to use, let me get back to my colors here. I need to find out what my r is. I need to find out what my theta is. Notice I've also been given a restriction. I can only use thetas that are in degrees, and I can only use positive thetas. All right, so let's take a look. If I'm going to find my r, whoops. I've got an x value of 1. I have a y value of 1. My r value is going to be root 2 when I do the Pythagorean theorem. Then I find my theta, and my theta, smack dab in the middle of the first quadrant, is going to be at 45 degrees. Well, that automatically gives me one of my coordinates, root 2, 45 degrees. But remember, there's 2 ways to get to that spot. So let me erase my triangle. Remember that I'm really only looking at the coordinate. I can either get to my coordinate by going in this direction, which is how I got my 45 degrees, or I could also go in this direction, then using an, but I can't use a negative angle because my directions told me I couldn't use a negative angle. So I have to retract that a little bit, okay? So instead of using my negative angle, let's use the backdoor spoke, okay? So the backdoor spoke tells me that I'll have to use a negative radius. And the backdoor spoke, if I'm going to get there in the positive direction, I'm going to get there in this direction. And the backdoor spoke then is at 225 degrees. Okay? So the front door spoke had a positive radius and a positive angle. The backdoor spoke had a negative radius, but still had a positive angle. Still had a positive theta. All right, let's try that again. So when I'm looking at example number 5, I draw the coordinate like I would have in junior high. I go ahead and I find that my radius, you can use the Pythagorean theorem here, to find that your radius is going to be 2. Well, I know it's smack dab in the middle of the second quadrant, and so the only 45 degree position in second quadrant is going to be at 135 degrees. That gives me my first coordinate. So the front door spoke gave me my 135 degrees. Let's go to my back door spoke, which is going to be in this direction. I still want a positive angle. And so the back door spoke, first of all, is going to tell me to use a negative radius. And secondly, still have to use that positive angle. And the positive angle here is going to be 315 degrees. Let me get rid of some of my markings here so that it's not quite so messy. All right, next. Notice that you're asked to put a polar equation. Remember this is, to find a polar equation. This is r's and thetas. When you've been given the rectangular equation, the legs. You can see that this is a rectangular equation because you have x's and y's. Now let's look at the sticky note over to the side. These are three things that I already know. Notice that these two are legs while these two are r's and thetas. And on the third equation, Pythagorean theorem, notice that the left side of the equation is all legs and the right side of the equation is polar. Okay? So we're going to use our sticky note, things that I already know, to plug and chug. So let's use this first concept to plug in r cosine theta for x on example 6. So r cosine theta goes in for x. R sine theta goes in for y. -7 goes in for -7. And folks, I've done what I was asked to do. It said to find a polar equation, and I did just that. Now, sometimes in my lab, it will ask me to solve for r. And so if I were going to do that, I would just use the GCF of r, factor it out, and then I would divide on both sides by everything not the r. So that would be a -7 divided by cosine theta plus sine theta. So if my lab asks you to solve for r, then you would go ahead and isolate r. Otherwise, all you have to do is just simply convert from the rectangular equation into the polar equation. Let's do the same thing on number 7. So I have a 3. Let's take out the x and replace it with r cosine theta. Then I have a -2. Take out the y, replace it with r sine theta, equals 6. And again, if all you're asked to do is to convert your formulas, this is sufficient. But if you are asked to solve for y, go ahead once again and pull out your GCF of r. I'm sorry, if you're asked to solve for r, pull out the GCF. You'll have 3 cosine theta minus 2 sine theta equals 6. And then you can divide on both sides, isolating the r. So that'll be r is equal to 6 divided by 3 cosine theta minus 2 sine theta, if you're asked to isolate the r. All right, I'm going to go ahead and stop the video here, and then I will do a second video for this section that will only cover graphing. So go ahead and get your calculator out, and we'll talk about what kind of settings you need to have in your calculator, and I'll come right back and we will do the next part of the video.